Factoring special products. Our objective is to factor perfect square trinomials and the difference of two squares. Who uses this? Urban planners can use the area of a square park to find its length and width. A trinomial is a perfect square if the first and last terms are perfect squares. And now you got to look at the middle term. And then the middle term is 2 times one factor from the first term and one factor from the last term. So let's look at that. So if we have 9x squared plus 12x plus 4, 9x squared is a perfect square, 3x times 3x. 4 is a perfect square, 2 times 2. And then if we take one factor from here, so 3x, one factor from here, which is 2, and multiply that by 2, 2 times 3x times 2 is in fact 12x. So this would be an example of a perfect square trinomial. When you have a perfect square trinomial, when you factor it, it will always follow this pattern. So you have ax squared plus 2 times ab plus b squared. Well, in that case, then you're going to have a plus b times a plus b, or the quantity a plus b squared. If it's a minus, you would just have a minus b squared. So if it's a perfect square trinomial, look at whether the second term is positive or negative, and then that's what you use in the middle. Let's look at one. So for this one, we're going to determine whether each trinomial is a perfect square. If it is, we're going to factor. If it's not, we're going to explain. So if we look here, we have x squared plus 12x plus 36. So our first term is x times x. Our last one is 6 times 6. And then 2 times x times 6 is 12x. So we know it's a perfect square trinomial. You can either factor it the way you've done since the first few sections of this unit, or you can use the rule. By using the rule that's got a plus, so you know it's going to have a plus within this binomial here, and then one factor of the first term, a factor of the last term, and then that quantity is squared. Let's try another one. Alright, so we have 4x squared. This is 2x times 2x. And then if we have a 9, this is going to be 3 times 3. And now we need to check this middle number. So is 2 times 2x times 3. So if 2 times 2 is 4, times 3 is 12. So 12x, it does. So we're good here. So we know it's a perfect square trinomial, and it has a minus. So when we write out our binomial, there's going to be a minus here. So we write one factor of our first term, one factor of our last term, and then we square that quantity. Try this next one on your own. Okay, so we have x and x, and then this one we have 4 times 4. So it's looking good here. And now let's check our middle terms. We have 2 times x times 4. 2 times 4 is 8, so we have 8x. With this, not 9x. So it is not a perfect square trinomial. And the explanation would be that 9x does not equal 2 times x times 4. Now try this one on your own. When you return to the video, the answer will be revealed below. So our first and last term are perfect squares. When we multiply 2 times a factor of each, we end up with our middle value, or our b value here. And now we write it out. So we have x plus 2 because it's a plus, and that quantity is going to be squared. Alright. So if we think back to the previous chapter or the previous unit, we were learning that the difference of two squares has the form a squared minus b squared. The difference of two squares can be written as a product, a plus b, that quantity, times the quantity a minus b. You can use this pattern to factor some polynomials, but the polynomial has to be a difference of two squares. So there are going to be two terms, one subtracted from the other. Both terms have to be perfect squares. Okay, so if we look here, we have 4x squared minus 9. Both of them are perfect squares, and they're being subtracted from one another. This is the only time you can do a difference and subtraction of two squares. 1, 2. And then when you write it out, you write it with a plus and a minus, and you take your two base terms here. So we have a squared minus b squared, and that's going to be, in this case, it would have been 2x plus 3, and then 2x minus 3. So if we look at this example, the square of this would be x and x, and then this one would be 3. So we'd have x plus 3 and x minus 3. So let's try one. So we want to determine whether each binomial is a difference of two squares. If so, factor. If not, we need to explain. So we have a subtraction sign, so that's step 1. And x squared is a perfect square, and 81 is a perfect square. So we have x times x and 9 times 9. So we're going to have x plus 9 and x minus 9. And those two binomials will be multiplied to each other. Let's try another one. Alright, so we have 3p squared times 3p squared. And then for this one, we have 4p times 4p. And we're subtracting here, so we know we have a difference of two squares. So now we simply need to write it out. So we take one factor of our first term, one factor of our second term. One of them is going to be plus, and then the other one is going to be minus. That's got to be different. Alright, so now let's try this one. So if we split up x to the 6th, we get x to the 3rd times x to the 3rd. However, this is not a perfect square. So therefore, it's not going to work. So it's not a difference of two squares. You have to have a difference, and then both of them have to be squares for it to be a difference of two squares. Alright, so now that we've done some practice, try this one on your own. When you come back to the video, the answer will be revealed below. And there you have it. So the first one is a perfect square, second one is a perfect square. So you take one factor of the first, one factor of the second, one's going to be subtraction, and one's going to be with an addition symbol. And that completes our video on factoring special products.